But I am very excited to welcome the CEO of ZymoChem to the stage, Harshal Chokhawala. He has received his PhD in chemistry from UC Davis and worked as a project scientist at Cal and at Berkeley. He's passionate about science, and he founded ZymoChem, a renewable chemicals company focused on developing the next generation of microbes and bioprocesses for making chemicals and high performance material with superior economics. Harshal, I'm excited to hear more about your company. I know everybody else is, and I'm excited to talk to you after. So the floor is yours.
Well, thank you, Lindsay, and the LINC team for giving me the opportunity to share my story. I can echo a lot of the sentiments previously said. The DOE and a lot of the funding mechanisms through the DOE have been phenomenal. And without a doubt has been one of the biggest factors for our success so far. And so happy to speak to how we have leveraged these resources that are being available to us through different mechanisms and share sort of the lessons that we've learned and sort of how we've used that funding to get to where we are. But before I get to that, let me tell you a little bit about ZymoChem and what we're building over here and why. And so to the Bay Area crowd, it should not be a surprise that biotechnology is literally disrupting every aspect of our life. And this is what we're using at ZymoChem, using biotech to literally deliver high performance materials and chemicals that are both better for you as well as better for the planet at a price that the consumer can accept. And so, as you already know, biotech is disrupting a lot of these traditional industries, from textiles and dyes to cosmetics, to plant ingredients, impossible foods and others. But one of the key things that is driving this has been the ability to engineer biology at cheaper and faster timeframes than never before. Unfortunately, widespread disruption in this industry is still missing. And the key reason for that is it's been incredibly hard to come up with biotechnology solutions that have the right combination of scale, performance, and cost, right? Obviously, there is sustainability that's always present, but it's the combination of these three things that's missing, that's, as a gatekeeper to preventing disruption across all these industries. This is where ZymoChem comes in. Back in 2015, when we started, this was the problem we wanted to solve. And then over the past 5 years, through a variety of different funding mechanisms, what we have built at ZymoChem is sort of the world's first platform that allows you to deliver solutions with these three properties. And so let me tell you a little bit about what we call this. We call this as a carbon conservation technology platform, which ZymoChem has developed. And this platform, when we started to think about this, we took a very different view than anybody else in the field. And we sort of did three things very differently to allow us to deliver a platform that can give you the right combination of cost, scale, and performance. And so one of the first things we did was we actually completely de novo designed how chemicals and materials get made inside microbes. So we use very little of native biosynthetic pathways and instead engineer completely non-native biosynthetic pathways inside these microbes. And when I say non-native, these enzymes and these pathways don't exist in nature. And the single purpose of doing this was that you lose a lot of carbon in the form of CO2 when you use natural pathways. These de novo pathways were designed to eliminate the loss of carbon and CO2 when you make different chemicals and materials. And what that ends up turning into is you just have a lot more higher theoretical yields than what the state of the art is. And this translates to much less utilization of sugar or feedstocks, renewable feedstocks, which is the single largest driver of cost of production. The second issue that we wanted to tackle was scalability. This wasn't trivial when we started. A lot of issues in terms of predicting and scaling processes up to commercial level. And so what we took from inspiration from nature was the ethanol process, wherein you grow up yeast aerobically and you make ethanol anaerobically, one of the world's largest scaling processes. And so we designed our pathways and microbes to actually function anaerobically, which allows you to inherently scale with very low operating expenditure. And so when you combine the higher theoretical yields with this scalability, we have actually very low cost and a scalable bioprocess. And so we have, phenomenal cost structures possible versus petroleum-based chemicals or targets that don't exist today. as you can imagine, this was like a basic science idea when we started, and now we have basically proved this technology out for more than 20 different targets. Multiple of these targets are now at pilot scale. And our business model is to commercialize this technology for specific products and partnerships with industry leaders. And obviously we are doing this for many different products, but a product I can talk about publicly today is where we are in a multi-year collaboration with a large chemical company to make and sell a particular product that they use using ZymoChem's technology. So how did we get to this stage? So a little bit more information, sort of non-technical, on how we built ZymoChem. And so up till now, we've done about 6 million in R&D, and I'll get to the strategy on why we chose it to build a company this way. We're based in San Leandro, currently 12 full-time employees. We're actually doubling in size to 25, and have literally tons of roles across fermentation, process development, RA, scientist, and director levels. So one of my asks for the audience is if you really want to use biotech and are passionate about biocatalysis, enzymes, and products and polymers that make people's lives better, and want to work for a very energetic startup, please reach out to me. My address is over here, or visit our website and get in touch with us. We have some phenomenal investors. We have some phenomenal partners that I can, that are listed on the slides, and more, which I can't talk about today. But very excited in sort of building out the team at Zymo. So we're now sort of entering a very big growth phase within the company. But before that, it took us a long time to get where we are. And this is how we've started thinking when we started to build the company, is building de novo biosynthetic pathways that don't exist in nature is hard, right? It's like a fundamental science thing. And so when we started the company, the science risk was very high, but the payout was also very high. And so we started to think about literally funding mechanisms in which it would allow us to establish sort of proof of concept for our technology. And we started to think about, how can we do this in a capital efficient way so that you can preserve ownership for the company as well as make progress? And for that particular reason, we had mission alignment with DOE, NSF, and USDA, and we started writing a lot of grants, particularly phase 1 and phase 2 SBIR. So we've raised some money through that, and that's literally allowed us to get proof of concept for our technology. And then over time, especially over the last couple of years, we started to access DOE's facilities, particularly the Agile Biofoundry via the direct funding opportunity. This is a CRADA agreement that we had with DOE to particularly leverage really advanced techniques and knowledge that the DOE has that as a startup, less than 10% startup don't have. And so we've also leveraged that for success. And then finally, as Todd was mentioning, we've partnered with LBN and ABPDU, especially on the scale-up side of things. This is very expensive, particularly the infrastructure to build. It's very expensive to run, and it is very hard to have personnel that really understand this. And so I really want to plug in over here for LBL and ABPDU. They've been phenomenal partners for us and allows us to do things that we just couldn't on our own. And so really great opportunity to partner with labs that offer you these capabilities. And then in the Agile Biofoundry side, we're partnered with both Lawrence Berkeley Lab as well as Oak Ridge National Lab to leverage our metabolic engineering and strain engineering capabilities as well as scale-up capabilities. And so I'm happy to answer some of these questions, but I hope I was able to communicate to you why we chose the path we did for building the company using non-dilutive expertise as well as dollars. And one thing I would like to add over here is, when we started, there was a perception that it's really hard to work with the DOE. I think Vanessa mentioned a little bit about optimization of the CRADA agreement and the IP rights and other things. On our end, we found it to be a real breeze. It wasn't a lot of effort or time to get through these agreements or massage these agreements to get the necessary IP rights. So I would really like to congratulate the DOE that I think they've done a phenomenal job at making sure that these templates and the IP rights associated with are friendly and low barriers for entry for small startups like ZymoChem.
Great, thank you, Harshal. Again, if you have any questions for Harshal, please put them into the Q&A and we will ask you in the time that we have. So go ahead, put your questions in that Q&A icon at the bottom, but I selfishly am going to kick things off. Harshal, one of the things that you said that really stuck out to me, you said the science risk was very high, and the science risk was very high, but the payoff was also very high as well. And you leveraged those funding mechanisms to really get your proof of concept. Can we deep dive a little bit in how you as the CEO came to that decision and said, this is the best path for me?
Yeah. So before that, I was in academia, so I was really good at writing grants, right? And then there was also this opportunity where we could leverage the novelty of this along with the types of mechanisms that the DOE was funding. Right, so that was one option versus going to venture capitalists and raising money as a seed round. And because of the novelty of the technology that we had and the mission aligned with the DOE and other institutes, we found it that raising money through this route was actually much less dilutive and frankly aligned to what we wanted to do. And so that's the route we took as a company. And it's not a small check, right? Like typical seed sizes back in 2015 were $500,000 versus phase one SBIRs are 150. Now they're 250, for example, with $1 million or 750 in phase two. So it's not a small amount of check in any capacity.
Right, we had a question come in from Joy, and I think it's a good one. You mentioned quite a few partnerships that you guys have gone through with the DOE labs. So I'm curious if you can kind of walk us through. I know you guys have had CRADAs and SPPs, and you've gotten these vouchers. Can you kind of give us a step-by-step as to what the order of operations was for you, or which ones ran concurrently, and just kind of speak to what your partnership pathway was?
Yeah, so there's three levels in which we think about this. So the first was to get basic proof of concept of what we were doing, which is what we primarily used SBIRs for. And then the second phase of the SBIRs is when your technology starts to mature a little bit. This is the phase two SBIRs, which is what that was primarily used for. We started to get into CRADAs with the national labs, especially the LBL and ABPDU. You know, they have phenomenal scale up and downstream capabilities, 50, 300 liter fermenters and downstream capabilities, and people were really knowledgeable in that. As a startup, that was a lot of capital and time investment, which we didn't want to get into. So when the DOE presented us with the opportunity to partner with the labs to put your technology in their hands and scale it up, we kind of really jumped on it, right? And so that was one of the things we did with SPP and Todd when he was running ABPDU back in the day. And then it was essentially, we would look for synergistic opportunities on when it would benefit ZymoChem's technology plan and get it accelerated using the DOE's capabilities and vice versa. So for example, in the most recent CRADA, what we contributed to this was our C2 technology, like, and then what we were leveraging from the DOE and Agile Biofoundry was their tools and capabilities. And so it was a real good marriage between what we could give to the Agile Biofoundry and what we could leverage from them for a mutual sort of, next step for the company and for the Agile Biofoundry. And so it was always mission aligned for us. And we've leveraged these capabilities as they've become more and more mission aligned along the different paths. And so, long story short, regardless of what the stage of your company is, if you're proof of concept, you're sort of in the middle or towards the end, the DOE has various programs along the entire axis of development that you can leverage to kick this off, right? It's not end all be all, but it definitely helps you to get to a more mature, TRL level.
Yeah, absolutely, Harshal. And I am sorry to say that we are out of time for questions. You'll be sticking around as a panelist, so if you're comfortable asking or answering a few of those in the QA, feel free to reach out to Harshal here and he'll answer your questions. But thank you so much for giving us that insight. And I think a theme that we're seeing throughout is that there's lots of ways to leverage these national lab resources regardless of the stage of your company. So thank you so much, Harshal, for joining us. And we'll put more information about ZymoChem into the Q&A chat.